Alright guys, now we're going to actually wire up the 210 wiring board for the actual electric heat. First thing I must do is energize my transformer primary side. I'm going to designate this side of my terminal block to be L1 and this is L2. L2 will be my hot for my circuit. The neutral off my transformer, I'm going to take it to ground because ground and neutral has the same value. Being I don't have a neutral on this board, I'll just actually use the ground. Then my secondary side, I'm going to take my 24 hot and I'm going to put it into my actual thermostat. So whenever I switch these contacts in the call for heat, W will take the signal from here. And W will take that signal and put it into the bottom of my sequencer. When wiring up, make sure you have good contacts. If you don't have a good contact, you will lose your voltage going to whatever you're trying to actually control or put it to. I will come out the other side of my sequencer and I will go to my 24 volt common. Alright, so now the 24 volt and the transformer are all hooked up, so my 24 volt circuit for electric heat is hooked up. The next thing I'm going to do, I'm going to come back over here to my L2, which I've already said is my hot. I'm going to come off my L2. I'm going to put power on M1. M1 has power coming in. M2 is where power comes out. I have two terminals here. Those two terminals, one of them must go directly to the blower motor because I always want my blower motor to come on anytime my elements are glowing. Alright, the next one can go into an element. So these two terminals right here will go into my loads. So I would take the first one off of M2. And I'm going to actually put it into my blower motor. Remember we discussed earlier, we normally use the medium speed for electric heat. It's not always the case, but that's what we want to use at this time is the medium speed. Alright, the common is the white. I need to take the common from my blower motor and I need to also put it down here on my terminal block. But instead of going back to L2, I'm going to go to L1. That is my common side of the terminal block. Now I'm going to come out of here, which is the same terminal which I used to put into my blower motor, which is the M2. I'm going to come off of M2 and I'm going to go into my limit, which is going to feed the power, which has a jumper that jumps it into the ceramic insulator. It comes back out of this other side. It comes into the other ceramic insulator and it goes to my fusible link. I'm going to come out of the fusible link and I'm going to go back to the common. Remember we designated L1 to be our common. Alright, I'm going to go back to my power supply one more time. Make sure that I'm making a good connection. I'm going to come off of there and I'm going to take the power into M3, which is a contact directly under M1 and M2. I'm going to come out of M4. I'm going to repeat what I just did on the last step when I came out of M2. M4 goes into my limit. Limit jumps over to ceramic insulator. It goes into element. Element comes out on ceramic insulator. And it goes back around over here to my actual fusible link. Come out of my fusible link. And I'm going to make a connection back to the common side. Remember, the common side is the opposite side. I brought the power in on the sequencer. So I need to make sure I take it back to L1. That is acting as my common. Alright, then I'm going to come over here to my actual breaker box. The first video, we actually made sure we have power in here on our line. And we know when we put our disconnect in, we get power on the load. Put your disconnect in, close the box. Come to your thermostat, make sure your temperature is turned up, auto, switch it over to heat. And remember, the sequencer actually has to warm up. 24 volt goes in it and it has to actually warm up. When it warms up, blower motor and element should come on. And you can also hear the contacts as they close. Look at this one, see what's going on. There's the blower motor. You won't be able to really see the elements because the air from the blower motor is keeping them cool. But you can feel the heat coming off of that. If you take the blower motor out of the circuit, the elements will start to glow and they will actually open up that limit, killing the power. If you come over here, you can actually see the elements are glowing on the very end where the blower motor is not able to put air across them. If I actually come over here and I kill either the common or the hot leg to the blower motor, it will come out of the circuit and the elements will continue to glow until they open up the limit.